Let's get started with 5.2, properties of rational functions. All right, what is a rational function? A rational function is a polynomial divided by a polynomial. So let's find the domain of a rational function. So we have polynomials in the numerator and in the denominator. So just a quick review here. We've done domain a lot. Domain is what can the denominator not be? 0. So x does not equal -4. We would need a factor here. This could be x plus 6, x plus 2. So x does not equal -6 or -2. In this situation here, x squared plus 2 does not equal 0. So x squared does not equal -2. Well, that can't happen because you can't square root a negative and get a real answer. So our domain here is all real. 3 can't equal 0. Well, that's always the case. So again, all real. And lastly here, x does not equal -2. Why show this one? Because if you factor the numerator, you'd get x minus 2 and x plus 2 all over x plus 2. And those x plus 2's would cancel, leaving you with just x minus 2. But even though they cancel, you got to go back to the original and look at the denominator, or look at the domain. All right, so try problem 13. Find some domains. Okay, so we're going to introduce the parent function of 1 over x squared, and 1 over x squared looks like this. It will only exist in quadrants 1 and 2 because whatever the x value is, positive, if you square positive, you get a positive y value. If you have a negative x value, what happens if you square it? You get a positive y value. We do have an asymptote here. We've talked about asymptotes before. If we have x be 0, we would get an error. Can't happen. Alright, so we have two asymptotes here. We know that x equals 0 is an asymptote, but also y equals 0 is an asymptote because we'll always have positive y values because we're squaring. Alright, so there's your parent function. There's an example of some points in here. So these are some good common points in here, but mostly we're going to be worried about the asymptotes here. So let's graph this. We know about transformations. We can do this. Let's think about our asymptotes. To the right 3. You can make your lines a little straighter than mine, a little harder on the stylus here. X equals 3 and y equals 2 are going to be the asymptotes. They will take off like this. Don't forget to put arrows on the ends of them. They do go forever. Alright, try problem 31. Okay, so let's talk about asymptotes here. Horizontal asymptotes. Now, horizontal asymptotes, we've talked about being stretched towards them. So when x gets really big, approaching infinity or negative infinity, we will get very, very close here to the asymptote. But that doesn't mean that we can't cross it. So we could cross it, but then eventually come in really close to it. Alright? So something like those. A vertical asymptote, however, will never ever be crossed. Alright? The graph of R never intersects a vertical asymptote. So, vertical asymptotes like this. And lastly, we have one other asymptote we haven't talked about before, and those are called oblique asymptotes. These are the word for diagonal asymptotes, the word oblique. Alright, and so maybe your graph goes up and down, but then eventually gets really close without moving, wiggling, to some diagonal line. Alright, so we'll worry about those in a second. For now, try problem 23. Alright, so let's find some vertical asymptotes. So, the vertical asymptotes are going to simply be the factors, the zeros of the denominator. So, same as the domain. So, where are your asymptotes? We do the same steps as finding domain. But in this case, we'll say equals, because we're saying what's the equation of the asymptotes. Alright, so x equals -3. X equals plus or minus 2. Factor, x plus 4, x plus 1. X equals -4, -1. And in this case, x equals plus or minus 2. Alright, same principle as domains. Try problem 45. Alright, so here's some graphs of rational functions. So this is x minus 1 to the first. It's an odd function. Notice how the curves are in quadrants 1 and 3. Asymptote, vertical asymptote at x equals 1. Same exact thing here, except for we're in quadrants 1 and 2 with a vertical asymptote of x equals 1 for an even function. Guess what happens with the odd one cubed? Same as x to the x minus 1 to the first. X minus 1 to the fourth, exact same thing as x minus 1 squared, except for the steepness. It's going to go a little steeper here, just like x cubed, x to the fifth, x to the 7 are similar, and x squared, x to the fourth, x to the 20th are all similar, even versus odd. Alright, so there's some definitions about that, but you get the general idea. Let's talk about horizontal or oblique asymptotes. Okay, so here's your rule. We're going to talk about these polynomials, and so we'll have some r of x over q of x. Those, I think, are the letters the book uses, but it doesn't really matter. We're going to talk about the degrees of the numerator versus the degree of the denominator. Okay. So, situation 1. We'll call the degree of the numerator n and the degree of the denominator d. If n is less than d, if the denominator wins, you have a horizontal asymptote at y equals 0. If n equals d, you're going to have a horizontal asymptote at y equals divide the coefficients of the leading terms. For now, just write this down. This will make sense when we do an example in a second. Divide the coefficients of the leading terms. And lastly, if the numerator is bigger than the denominator, the degree, then we're going to have an oblique. It's the only case you'll have an oblique at y equals the long division. Just write that down, that'll make sense in a second. Alright? So this is the shorthand note-taking version. All the steps in the book, if you want to go back and take a look at those, but this would be the shortcut note version. We'll talk about all these in class too, but these are your 3 steps. Make sure you have these 3. They come up a lot. Alright, let's try this. Here we go. Alright, first situation. Sorry, n equals 1, d equals 2. Denominator wins. What's your horizontal asymptote? Y equals 0. Boom. Done. Alright, so we have this. If it's improper is the phrase you use if the top is bigger than the bottom. Sorry, I meant to cut that out there. This is kind of just an update of the slide we went over, or the notes, 3 steps I went over. Alright, but let's take a look at this. N is 2, D is 2. So here's what we're going to do. We're going to take the leading terms. Y equals 2x squared over 1x squared. Y equals 2 over 1. Y equals 2. There's your horizontal asymptote. Okay. Try one more of those. 6 versus 6. So y equals 5 over 2. Now here's why this is the case. Think about what happens as x gets really, really huge, like a billion. Alright, a billion to the 6th is so big that a billion cubed plus 3 won't really matter at all. Same thing here. To the 6th is so much bigger than to the 5th when x is really large that these parts don't matter at all. And remember, the asymptote horizontally is what happens as x gets really, really big out in this direction. Alright, so we divide the coefficients of the leading terms. Try problem 41 and 43. Alright, lastly, let's talk about some oblique asymptotes. So here, n is 2 and d is 1. We're going to do some long division. Now, this will only come up if n is greater than d by 1. Alright, so add that back into that note of the 3 steps. N has to be bigger than d by just 1. In this case it is 2 versus 1. So let's go back into our bag of tricks and do some long division. Might have been a little while. Can't remember how long ago we did long division, but we're back again. X squared divided by x is x. Multiply them in. X times x is x squared minus 2x. Subtract down. We have 6x. Bring down the next term and start all over again. 6x divided by x is 6. Multiply through 6x minus 12 and subtract straight down, and we have 13 minus 2. Alright, so where can you never get to? We can never get to the line y equals x plus 6. The part of the dividing that's not the remainder. The reason why is that no matter what number you pick for x, it'll always be slightly off because we have this little remainder on it. This is the part we can never get to. That's why it's an asymptote. Alright, so that will do it for here, for 5.2. Here's a summary of everything we've just talked about. You can get those down out of your book or pause this if you really want to. And that will do it for 5.2. Alright, any questions? We will go over them in class, and good luck with those problems.